In this video, we're going to be doing exercise 6.4 of the website that we've been using for a while now, where we're doing the exercises from this website. So we're going to have the package, and we're going to name the package the name of the exercise, which is all of this. I'm just going to paste it here, and I'm going to have underscores instead of spaces because packages don't take spaces. I think the classes don't take spaces as well. I could be wrong, but we could even try that after. So we have this package, and basically what's going on in this exercise is that we have um, an interface, and then we have a class that composes of an instance of another class. So it's a strong relationship where one cannot exist without the other. So let me just move this to the right so we can see the classes and then minimize this. So we have the interface movable. So public interface movable, and then we have the abstract methods. Um, Public abstract void move up. Public abstract void move down. Public abstract void move left. Public abstract move right. Void move right. That's it. That's all it is for the interface. What we have to remember about interfaces, from my simple understanding, is that it's just a blueprint for other classes that inherit from it. Implement it, actually, I mean, um, to enforce the other classes that implement the interface to have the same abstract methods and abstract variables or instance variables of the class. So next we're going to have the classes that implement it. So we have movable circle, movable point. Let's see if we can. Yeah, so you can't have spaces for class names. So we have movable point, and it has instance variables which are protected, I think. What's the curly brace again? Is it class diagram? No, not this website. Geek for geeks, please. So it's not even necessarily that. Access modifiers. Whatever. Really? Which one's the curly thing? Sorry, let me just pause this and I'll get back. Okay, so it's actually just package. So package is the curly thing. Int x, y, x speed, y speed. Whoops. So how do we do a capital P? So I guess for package, you just leave it as the access modifier as default, which just gives access to anything within the same package. So next we're going to have let me just minimize this. We have the constructor here, which is a parameterized constructor. So we have movable point int x, int y, int x speed, int y speed is x x, this dot y is equal to y, this dot speed is equal to x speed, this dot y speed is equal to y speed, and then after that we have we're overriding the toString method. So public to string return string dot format. The way you want the string to be formatted is so that there is the x value here. So we'll have the format specifier, which is of type integer, so it's %d for, I guess, decimal. I don't know. Same thing for the y value. And then speed is equal to %d, %d for the x and y speed, I'm guessing. And here we'll actually get the values from the arguments that are passed. So this dot x, this dot y, this dot x speed, this dot y speed. After that we have the move up method. So public static, public. Oh, we have to implement movable. So there's an error because we didn't implement all the abstract methods of the interface. So we're going to have to do that now. Public void move up this x plus equals 1. So we're adding 1 to x. I don't know if that's what you're supposed to do for a movable point, but I'm assuming so. Public. What really matters is knowing how to read the UML class diagrams and being able to use all the concepts of programming, and remembering all your syntaxes and stuff like that. So public void, the next one is move down. So I'm assuming the y, the x, so is it y and x? Right, so up and down is y, pretty sure. and move left and right is x. Void left. So here would be this dot x. Move left is minus, and then move right is plus. X equals plus equal 1. And then we have the, so that's it for this class. No, there's no more errors because we implemented the abstract methods of the interface that we implemented into this class, movable. Let me just close this, and this. And then we have, I mean, this is a very simple exercise, right? So I guess doing it in real time isn't a big issue. But for more complicated exercises, I guess I'll just pause the video, do the whole exercise, come back and then explain what I did. Next, we have the movable circle class, which composes of one movable point. So that means that um, the movable circle can't exist without a movable point. An instance of movable point is what they're saying. That's what composes means. That's the kind of relationship that it is. It's where the movable circle, it must have one movable point, otherwise it can't exist. Um, so if the diamond that we see here was filled in full black, and that would be aggregation, I think, which means that one can't exist without the other, I think, if I remember correctly. Um, Whatever, we'll just move on from there for now. So there's just two instance variables here. There's a private int radius and then a private instance of movable point center. Um, Sorry for the noise in the background. We're doing renovations in the house. So we have movable, we have the parameterized constructor of the class, movable circle, int x, int y, int um, x speed, int y speed, and then so interestingly enough, all of these values are the values they would use for a movable point. So I'm guessing here what's going to happen is that there's also the radius, but there's no center. Int radius. So this dot x is equal to x. So what I'm guessing is that if we create a movable circle in this instance, we would be creating a new instance of, yeah, in this case, I think we would be creating a new instance of movable point. Pretty sure. Interface called movable point, which contains four abstract methods as shown. Um, yeah, these are method overriding as well. These are all method overriding. because this implements the other class, in which case this also implements the other class. Uh, yeah, let me just go ahead and write down that this is method overriding as well, and this as well. And then here we have this. So I think in this case we're actually creating a new instance of movable point. So just a new movable point, and then int x, x, y, x, y, speed. Yeah, so when we create an instance of this class, we are creating a new instance of movable point as well. And then this dot radius is equal to radius. I wonder if this dot center is supposed to be the new movable point, because that's what it says here, right? So that would make sense. So next because what we need to understand is that movable an instance of movable circle contains one instance or composes of one instance of movable point, right? It cannot exist without an instance of movable point. So when we create the instance of the movable circle, we create a new instance of movable point, right? And we store it as center because the movable point is this is basically declaring that this class, every time there's an instance of this class, it has an instance of movable point. That instance will be stored in center, and it will be associated with the instance of this class. And the instance of this class also has a radius. Um, so next we have the toString method, which is method overriding as well. And here it's public string to string. As we all know, we've been using it for quite a while now. We must return a type, a data type string. So we're going to return a formatted string, in which case they want it to look like this, the string to look like this. So here we're going to have the format specifier %d for the integer, %d for the other integer, and then speed is equal to, and then %d for the other integer, %d for the other integer, because they're all integers here. And then we have a radius, which is an integer as well. There's no space there. So we have another format specifier taking an integer. And that's it. For the arguments, that will basically pass the values to the format specifiers. They'll be output here. It'll be this dot x, this dot y. No, I don't know why I did that. This dot x speed, this dot x y speed, and then finally we have this dot radius. So x speed cannot be resolved or is not a field. So the right way to do this is, since the instance is called center, we would just use the keyword center. We would just use the, the variable name for the instance. So center is what recognizes and what has these values associated with it. What's the issue here? XP cannot be resolved. Uh, it should be able to be resolved. For now, let's just move on to the next. I was just looking at the composition on Geek for Geeks. But anyways, so next we have let's see here, we have the overridden methods that we must implement. So since we implemented the interface movable, so we have the public void move up. This dot center dot x plus equals 1 override, and here it is public void move down. Now we're moving down. Center.x. So move up, right? That's for the y value actually, so I'm wrong here. Center.y plus minus minus equals 1. And then another overridden method, public void move left this time. So center.x minus equals 1, so we're subtracting 1 from x. And then gotta remember that x is an integer value. So override public void move right. And here it's center dot x plus equals 1. So now back to here. Seems to be some kind of issue. I saved it and then there isn't any more issues for some reason. That was weird. So that's the exercise 6.4. So in this case, we have to remember that here it's not this keyword that we're using to refer to these values. The new instance of movable point that we must have with this class, since this class composes of one instance of movable point, since because of this instance variable here, it means that this class composes of one instance of movable point. And in this case, and it's called center, right? So here, this dot center is equal to a new instance of movable point with these values, which are true because movable point does have these values. So we know that center has these values, and we use center as a keyword, right, for the instance, and then we get its values, its attributes, the values associated with it, with its attributes, and yeah, it's a very simple exercise here. Thanks for watching. See you guys in the next video. We're probably gonna do 6.5. I think so. We'll see.